Now we're going to talk about function notation. So normally we'd have an equation like this, y equals x squared. And if we wanted to evaluate it at a number like 4, we would plug into the x and get the y. Well, that's the same thing. It's just that y is now being called f of x, and it's for good reasons of simplifying things in notation later. So for this one, we're just going to evaluate at x equals 4, and here's the notation. You put f of 4, and you say f of 4. That's what you say. F of 4 equals, and you put the 4 in for wherever the x occurs, and you get 16. So in other words, 4 went into the function box, which was squaring it, and only one value is going to come out of there. It's going to be 16. So it's a function. X squared is a function. And then over here on this second one, square root of x, that's calling for the positive root of the x. So if we put f of 9 for x equals 9, we put it in the function box. The box says to take the square root of the 9. Since it's only the positive square root, that comes out 3. And that creates a point 9, 3. And over here, this one created a point 4, 16. Now, interestingly, if we were on this same square root one, if we would put negative 9 in, that would be the square root of negative 9, which would be not in the real number system, so undefined, not in the real number system. It's in the complex number system, which you can learn about later. And so negative 9 would not be paired with anything. It'd be like question mark. It'd be blank. That means that negative 9 is not in the domain of the function. Because it's not in the first coordinate list of the points of the function, because negative 9 comma anything isn't a point in the function. So anyway, that's function notation, and that's pretty much all there is to it.